take our shrink tubing, do any tinning beforehand, before you use your shrink tubing, so that you have some nice fresh solder on your motor wires. Okay, there we go. Don't breathe the fumes. Try not to. You will get old one day. Okay, now we're going to tin the actual leads here on the short ESC wires, which are a bit rough. Can be a problem for getting the shrink tube over if you're putting on too much solder. So let's hook these up in reverse parallel order. We're going to reverse one of the leads that's in parallel order, because all the wires have a direction of manufacture. So with that in mind, we're going to put on our shrink tube first. With that in mind, you can just reverse two of the wires in parallel with your ESC pads, and you'll have your counterclockwise or your clockwise depending on the motor manufacturing. So then you don't have to power it up every time and check. Once you know your power leads orientation, you can depend on the manufacturer to probably use that same pattern of coil winding. So there's a little less guesswork that way. Let's put this wire on, or this shrink tube there. Now we're going to put this one here, which is opposite. We lost our shrink tube for that one. Right? Also going to clean up this wire a bit. Maybe cut it down a bit. Get our piece of shrink tubing. There it is. Put it on our wire lead. Touch our lead to the tip here. Bridge it with the solder. Might need a little bit more solder on that. There we go. And join. Let it cool. Can help by blowing on it. Put your heat shrink tubing over top. Pull back the last wind. This should be counterclockwise if my Tiger motor pattern assumption is correct. And we'll test it in a second here. That's done. So that motor is on. We're going to hope that it's going to be counterclockwise. A bit of a wire management issue here, but again, I'd rather have more wire and room to move than have less wire and no area to solder. So while that's warm, we're going to bend those back like that. You can use some tape later to attach those. Let's find a screw. I have to dig for a screw here, which is unfortunate. Okay. Box. Going to be getting some batteries in this week coming up. I'm going to get a couple of orange lipos from Ready Made RC 1800s, as well as a bunch of tattoos. We're going to get a Gens Ace 2200 3-cell to test. We're going to run that against a 2200 Gens Ace to see if there's a big difference between the Gens Ace standard and the tattoo. And then we're also going to be running a larger tattoo, or the 1800 tattoos, in comparison to the ready-made orange 1800s, which have a higher kV, so we won't be comparing them on that basis, but we will be comparing them on how they feel and what kind of punch out they have when we're flying. So I tend to be one of those people that buys excess amounts of screws and then promptly puts them somewhere where they are unavailable for use. There must be thousands of M3 screws lying in carpets all over the world right now. Okay, we are going to look one more spot. I just need one. I just need one. Just to test my motor. Well, I found one that's too long and one that's too short. I don't think this is going to work, but it might hold it for our test. It's just too short. Using 3mm arms here. I might have got it in there. I have about 4 threads on it, I think, not even. Okay, let's test this motor. It should be counterclockwise, based on my assumption that the motors are all manufactured in the same way. So let's turn on our receiver, our transmitter, get some power into this. Make sure our free wires are not touching the carbon fiber. And I also put OSD on this one, so it's counterclockwise. So reversing those wires, if you hook up 3 wires from the ESC to 3 wires from the motor in order, in line, then you will have one direction. Once you've determined that the direction going to your pads of your ESC is parallel, then just switch those 2 and you've got your counterclockwise motors. Each motor will be the same in manufacture if they're made in the same batches. So that means that you don't have to worry about this testing by hand like I'm doing here. So let's unplug this before we fry the other motor ESCs and attach our other motors. So here's our next motor. We're going to be clockwise, so we're going to run these wires, as you see here, in a row to the ESC pads in a row, and that will be clockwise, because the counterclockwise required me to cross over 2 of these wires like this. So remember that, and that's your motor pattern if you're using all the same motors, of course, which you should be. Don't think that you should probably be mixing motors. I tried that once actually, and it was quite a challenge for the copter to stay in the air. So let's put our shrink tube on. I'm pretty excessive on the shrink tube actually. I could probably cut these down, but it's sort of a bad thing to waste it. But I'm not going to use those little pieces now really. There we go. We'll cut them down a little bit. I'm glad that I have an electronic shop like 20 minutes away from the house, so I have lots of shrink tubing and stuff like that on hand, and soldering equipment. They have a nice Hakko soldering iron there for $125 Canadian, which I would really like to buy, but so far I'm using this standard. I guess you guys would call this a harbor freight.